AppAqua, which is just a research cluster of Appalachian faculty, grad students, and undergrads, and staff members now that are focused on water quality issues around the high country. Um, this is a kind of a retooling of an old presentation I gave years ago about using these instruments I'm about to explain to you guys for doing water monitoring. And I'm going to demonstrate my age here a little bit and title this, You Don't Always Get What You Want, Kick Back to the Rolling Stones, or if you're a Trekkie, The Trouble with Trolls rather than Troubles with Tribbles. But I'm going to talk about data sondes and how we can use the data acquired from them to monitor long-term water quality issues. And I just want to acknowledge a couple of my colleagues from the Geography and Planning Department, Jeff Colby and Derek Martin. I think Carolina had reached out to Jeff initially, but he's recently retired. And Derek Martin's still with us, but he's running the graduate program at Geography and Planning and kind of stepped away from us for a minute. But so I'll get to the last slide. I'll demonstrate that we've actually come out of Helene with new funding and new direction and about 6 different departments represented in our group. So we've actually expanded over the long term. Okay, so what I'm going to talk about is some data loggers that we've installed across the upper South Fork of the New River. I'm just going to call that the USFNR, Upper South Fork of the New River, which starts in Blowing Rock in Boone and flows north and joins the North Fork right at the Virginia line at the mouth of Wilson. And then from there north through Virginia and West Virginia, it's called the New River proper, right? So even though it's called the New River, you may have heard that it's actually one of the oldest rivers on Earth. It predates the rise of the Appalachian mountain chain. And apparently all the evidence to prove just how old it is out in the middle of the Atlantic Ocean or the Gulf of Mexico now. So it's hard to prove it, but the New River is not new, is one of the oldest rivers on Earth and an important of the 17 watersheds in North Carolina. It's one of the important ones for harboring some of our indigenous species, lots of endemic species that live there, and is in still pretty good shape as it leaves North Carolina. So we've installed these data loggers, which are nicknamed trolls. That's where the trouble with trolls comes from. And we've moved from a company called Insitu that was kind of the initial sonde builder. But they got pretty costly because they had to corner the market for a long time. And then another company, Eureka, has now come onto the market and they're a fraction of the cost. So we've switched to them as we've gotten into our now 4th generation of these sondes we put in the streams. They last for 3 to 5 years, just depending on the water quality of the stream. They basically are collecting water parameters that you can select from a list. We've gone with temperature because it's so important to the high country and the mountain region that our water stays cold. So as climate change occurs and the temperatures start creeping up little by little over time, we definitely want to know what's going on there because temperature pretty much delineates how much dissolved oxygen or CO2, basically gas of all types, water can hold. And there's a lot of critical temperature ranges for things like brook trout and aquatic macroinvertebrates and crawfish that are really critical to the health of our streams. Of course, pH will give us an idea if there's any acid or bases entering the stream through chemical spills. And then my favorite thing probably is specific conductivity, which is a way to measure how well water conducts electricity. And some of you may be surprised to know that water, if you got 100% water, it doesn't conduct electricity very well. It's not a very polar solvent, and by itself, it's not a good conductor. But as you dissolve salt in the water, so things like table salt or calcium, sodium, chloride, and any contaminant in the water, the specific conductivity will go up. I'll talk more about that later on. So it's a great general measurement of water quality. And if you have, our healthy streams are in the 30 range microsiemens per centimeter. And the contaminated ones are well above that, and I'll get to it later. Sometimes we measure dissolved oxygen as a measure of stream health and certainly the depth of the water. And then we create what we call rating curves to determine at certain depths of water what the discharge is at that particular site. And discharge is usually reported in cubic feet per second. And this is basically how much water is passing by a place in the stream every second. These loggers have been set up to measure every 15 minutes, which the intervals of 15 minutes seem to catch pretty much the dynamics of the stream during rainfall events, yet allow us to collect data incrementally so that we're not overburdening the batteries of these things because they run on 3D batteries. And we get out and periodically change those out. Um, and we've also used what's called ISCO storm samplers, they don't live out in the streams all the time. We can just place them out there, program them, and capture a rainfall event and look at what the water quality parameters do in response to the rainfall event. Or snowfall events. So sometimes we're looking at the impacts of road salts on our local streams up here in Boone. So we've got these in 7 sub-basins, and I'll show you a map in a minute. And the 8th location is where the outlet of all these sub-basins, as they come together at the confluence in the downtown Boone area, and then leave Boone heading north towards West Jefferson. We have another site on the Greenway there that kind of captures the average of all of the 7 sub-basins coming together and their impacts. So the things that we have to overcome to get this set up, which we did back in 2008 and 9 with the official infusion of funds, or original official of funds, I meant to say, from our provost, was to, of all the places we could place these, find suitable spots, and get them installed, which, initially we started off with a 4-inch PVC pipe with these instruments kind of sitting inside of them for protection from all the things that happen during high flow events. I don't need to explain that to you anymore. I think everybody knows what I mean now. So whether it's a rock or tree or a house that's coming down the stream, we try to protect these things because they are pretty expensive. We need to be able to access them easily without having to worry about private owners. So most of our sondes are actually installed on North Carolina Department of Transportation bridges across the waterways. So we have public access. That did require that we contact NCDOT engineers and get permission to do that, or have a memorandum of understanding with a private homeowner. We have a retired vet who's very conservation minded here in the high country, and he actually has a property with 2 of our creeks on it. So that was really useful. Periodically, we have to go out to the field to each of these 8 sites. We download the data off of the computers that are inside of them, change out the batteries, and then calibrate each of the probes that can be calibrated. So things like depth, pH, and conductivity, or dissolved oxygen, we have to calibrate them. So this is a great opportunity for our students to get experience working with these instruments and uploading the data to our GUI, which I'll get to in a sec, and doing the calibrations and the field work. So it's kind of fun to go to these 8 sites. Some of them are beautiful spots with waterfalls and lots of fly fishing, recreational uses around it. So it's kind of a neat thing to do. And a lot of our students get their dream jobs right out of school because of this experience they have with us. Now the big problem, although that's what I just explained, is a lot of problem, especially after the big storms. We have to go back and redo these installations. We lost 3 of them during Helene. And I'll show you some of that in a minute. But once you've got the data downloaded, we have to clean the data. Sometimes there's mistakes because the probes get buried in sediment, and so their readings are inaccurate. And so we have to be able to recognize that. We've got a number of means of doing it. And if the data is not representing the actual water levels, then we have to delete it. And then it's managed by going into a graphical user interface that, again, I'll mention in a second. Weather complications. So in the wintertime, the batteries die within 3 weeks, sometimes sooner if the batteries. So we have 3D batteries in there. Sometimes one of those batteries might be a little more on the older side or expired edge, and they'll die even quicker. So we lose data when the data sondes are no longer operational. In the summertime, those same batteries might last 3 months. So it's kind of have to keep a check on the temperatures, and then finding the time to get out there and working around student schedules and faculty schedules means that we often lose a lot of data. And this is the trouble with trolls is that we don't have any full-time folks that only work on these sondes. So it becomes kind of a second job for a lot of us. All right. So this is where we are. So this is Watauga County in the state of North Carolina. I know you guys know where it is. And the upper South Fork watershed is in color down there between Boone and Blowing Rock. And basically it's encapsulating the middle fork of the New River, the middle fork of the South Fork of the New River, which is here. And so Blowing Rock would be here, and that flows north into Boone. And then all of these other watersheds are also outfitted with sondes as well. And I just want to explain a little bit about the variety of these watersheds. So starting out with the most healthy ones, Goshen Creek, Winkler Creek, and Flannery Fork all drain the Blue Ridge Parkway property, which is obviously owned by the National Park Service. So the Blue Ridge Parkway kind of makes an arc underneath Boone and between Boone and Blowing Rock around right in here. And so these three creeks are draining mostly forested national park property, and they're very, very good health. So uh, those are kind of our reference streams. So we're comparing the rest of these sub-watersheds to these three. The Middle Fork and the East Fork are kind of in the middle of the range of water quality. Um, they have quite a bit of development. They've got large highways running through them, big neighborhoods, some deforested sections that are now cattle fields. East Fork even has a small airport in it. And so, but there's still a lot of wooded property on both of these I'm sorry, subwatersheds. So they are kind of in the middle as far as the water quality goes. And then Boone Creek and Hodges Creek are highly developed. They have a lot of impervious surface, which just means concrete roads, houses, places where water cannot seep into the soil. And so it becomes part of the stormwater runoff. And Boone Creek and Hodges Creek are highly impacted by road salts, for example, um, parking lots in town, whatnot. So a lot of the pollutants that enter the upper South Fork are coming from these two areas. And then also the State Farm region here, which just falls outside of these other data sondes collection areas. Right here, where the South Fork leaves Boone and follows the Greenway north to towards Ashe County. Um, this is our last data site here at State Farm. So what we're collecting here is basically the average of all the water that's come together in these confluences and leaves as the South Fork of the New River. Also, I just wanted to remind everyone, if you've got any questions, chime in while I'm speaking. I'm happy to answer as I go. So this is an example of what these sondes look like when they're installed. So again, this is a bridge abutment. We've used 4-inch aluminum pipes, and we drill holes in the bottom and put a cap on the top with a padlock. And the sonde looks something like this. Um, the batteries live up here. The computers are in the center, and then the probes are at the bottom. You're usually protected by a cover that allows the water to flow through it. And then with the cover removed, this is what the probes look like. And again, you can choose whatever probes you like. And then putting them someplace where they're likely to last. So bridge abutments, and if we're in more of a natural place like our three reference streams, sometimes we have to find a house-sized rock or a car-sized rock. And you can see here the flows coming from the right, passing to the left. And so we've kind of protected it back behind the flow on the other edge of this rock here, and just used a drill to drill through the rock and then bolt it to that. So these are on there really well. And so far, so good with the aluminum. The old PVC pipes we used to use actually somehow got cut in half during one of our high flow events back in 2017 and 2018. And to this day, I have no idea how it happened. It looked like somebody took a samurai sword and just cut it in half. Just incredible, the force that our waterways can create. These are the sondes we're using currently. I took them all out and calibrated them after hurricane, and most of them aren't working anymore. So I had to purchase a fourth group of these using state funds and some NSF, National Science Foundation funds through a partnership we have with NC State. But you can see the batteries live in this top part here. We can take off this part and attach it to a wire that interfaces with a laptop, and then we can download the data. The probes are at the other end here, and it's just giving you an idea what these things look like. So this is Jeff Colby and one of the neighbors in the Flannery Fork area that allowed us to install this on his property. So this is his personal bridge. This is a gauge that allows us to know exactly what the water depth is, actually deep, how deep it is. And we've installed the sonde inside this rolled aluminum pipe that's right here. And you can see how large this rock is. And I'm going to use this as an example of the power of Helene. This bridge is now downstream and on the bank, no longer being used. This rock actually moved 20 feet to the right, not downstream, but into the middle of the stream because the water apparently came around from the left where Jeff is sitting or standing and pushed that rock to the right and buried all of this in gravel except for the very top of this. So we were able to get our sonde out after Helene. But I went back a week ago to see if we could possibly reuse this installation site. And this rock is now completely buried in gravel, and they've abandoned the bridge and they've just been driving across the stream. So we're going to have to find a new place for it. By the hospital in the East Fork, we've got a sonde on a DOT bridge right there. So we realize this is a perfect spot because it's protected, it's easy to get to, and the water actually passes through here in a regular depth. So this is what it looks like now. So we mounted it to that place where the yellow arrows were, and it sits in the water there. This is some of the high school kids I work with every summer. It's part of the Summer Ventures in Science and Math program. It's a summer outreach program for the School of Science and Math, which they're in Morganton and the other in Durham. And it's an awesome opportunity to work with 12 or 15 brilliant high school kids for a month. They live on campus, and I involve them as much as I can in the AppAqua researchers. This is Derek Martin and Jeff and I, and this is, the thing. So this is year-round data collection. So in Boone, that means you work in the snow sometimes. This is Hodges Creek, one of our impacted streams, and Derek is working on creating our rating curve here so he can understand for every inch of depth increase what the discharge is going to be in cubic feet per second. So we can use what the depth is on our instrument over time in those 15-minute increments and then calculate how much discharge we have. So it takes a little simple math, but we can do that pretty simply using the computers. This is what it looks like today. So there's a lot of mud in this area. We had a lot of sedimentation, and these bushes had to be cut back for an hour and a half. This poor young lady's arms are absolutely covered in scratches now from that work, but it's still there. It survived the hurricane and is still taking data for us. This is Goshen Creek, one of our reference sites. And it's right off Bamboo Road, and the Mountain to Sea Trail is right next to us. This is what's left of the installation after the Helene. So big rocks got in, pushed our pipe backwards, broke some of the mounts here at the top of the bridge. So I've pulled off all these rotting pieces and replaced all of that in the last couple of weeks, put on new metal mountings, and now it looks something like this. And we're using the rocks to help protect them, the bottom of the sonde here now. Let's see. So I'm not going to go through this as kind of the boring part, but we have a whole SOP that we've come up with for the students to follow so that they they keep the instruments working appropriately. There's a lot of tricks to making these things work, and a lot of things can go wrong, as proven by the faculty teaching the students getting it wrong half the time the first few months. So it's actually a little tricky, but calibration, connecting the sondes to the data, making sure that the memory trips aren't overwhelmed. So we have to delete data once in a while, make sure the batteries are changed out, and also see if the probes are starting to drift in their measurements. So that means they're getting old and not working accurately anymore. And then we have to start replacing things. So there's a whole checklist to make sure that the installations are good, the calibrations are done. And we're trying to keep the students following these SOPs. And it's great preparation for the real jobs out there as they move into situations working for city, states, or government or national government doing this kind of work in the future. Okay, so the GUI, the graphical user interface, is basically an online database that can be searched for specific dates and times or precipitation events, whatever you're interested in finding from one of these 8 data sondes. And the water pressure in the sonde actually is converted to depth, and that depth is then converted to water discharge. So it gives us the cubic feet per second of water passing by each point, and then the temperature, pH, conductivity, and dissolved oxygen can be mined for data on top of that. So that's the basic metadata that we've got just from the sondes. Now, that would be a lot just to do that, but to apply this to usable uses for watersheds, you got to do more than that. And so I guess I've got some pictures of some of the damages from some of the hurricanes in the past. This is from the 2017 tropical storm that came through. This is the old PVC pipe that eventually got cut in half. And you can see our original mountings on here, but now we've switched this to aluminum. So each time we have a high water event, we have to go replace things, pull off some of the flotsam and debris that's stacked up on it. And it's just basically constant effort. This is one site on the retired vet's property on Winkler Creek. And it's done pretty good because it's pointing downstream, and any of the things that float downstream kind of bounce off of it and keep moving. But this was the site just on the other side of the same property where we had installed this in a root wad under a tree on the bank of Flannery Fork. And this is what happened after the storm. The tree disappeared. The installation site disappeared. We never found either one of them. So they're probably up in Virginia in Claynor Lake or something. So things change. Lots of things come downstream. This is the Greenway site at the covered bridge on the South Fork Greenway. And you can see there's a dumpster over here on a sewer line. Our installation site is right here. And so this site always has lots of trash built up on it, sediments built up at the bottom. We have to dig it back out again. So you just never know what you're going to have to deal with. And lots of sedimentation. This is what everything looked like after Helene, but this is from 7-8 years before that. Okay. All right. So the GUI. The GUI was put together by graduate students from the computer science program, and the IT support staff here at App State helped us put this together as well. And it's been migrated to and updated several times over the last 15 years. We are just in the beginning of putting this into publication and public use so that anybody can access it. So hopefully by the end of the year, we'll have this for anybody to access and look into. And I'm sure it's going to be heavily used once it becomes publicly accessible. So some of the initial results we've got from this work is that the water quality is strongly negatively influenced by impervious surface. So roads, sidewalks, parking lots, buildings. And we've done some evaluation to see to what extent the riparian zone or the buffer next to the stream affects that water quality and the impervious surfaces. And we determined that, we looked at 25, 50, 75, and 100 meters from the stream, and 100-meter distance gave us the strongest relationship based on the amount of impervious surfaces within 100 meters of the stream and its negative impact on water quality. I'll talk more about that in a minute. Um, Water quality is strongly positively influenced by the forested land coverage, you might imagine. So the more natural the forested riparian buffer is along the streams, up to 50 meters in this case. And you might know that for trout streams, we try to have a 25-meter buffer on those. So I'm sure 50 meters is always better, but you have to kind of meet in the middle sometimes. And I think that's where that 25 buffer came from. But based on our data in our watersheds, we showed that the 50-meter buffer is better at determining or will help create more positive impacts on your water quality. The other thing that became pretty apparent early on in the years that we collected this data is that we have three categories, and I've kind of already defined that as our reference streams, our kind of mid-level impaired streams, and our highly impaired streams, and I'll show you that in a minute. It also became really apparent that road salt applications in the high country during the winter months are having impacts on our fish and invertebrates, the aquatic critters that live in the stream. And that our stream discharge rating curves are really helpful at creating discharge levels during our precipitation events, and that our streams are highly, and we already knew this, right? But highly flashy, meaning that they go up and down within an hour of a big precipitation event. So this is some of what that looks like. This is this is an old map, so it doesn't have the Hodges Creek separated from State Farm yet. But what you're seeing here is a color-coded GIS layer that the graduate students in geography and planning put together for us. And the dark green are forests, the light green are pastures and yards, and the white is impervious surface. So that would be businesses, roads, parking lots in this upper South Fork land cover layer here. And then on the side over here, we're actually looking at the same subwatersheds, but now we're using the SON data to look at the conductivity of the water. So you can see the Boone Creek's conductivity, which is an indirect measure of dissolved salts in the water and pollutants, was almost 400. And this is the weekly means for conductivity for each of these sites. And the end is the number of measurements we've had within those watersheds at the time we did this map making, which was quite a few years ago. But these haven't changed much at all. So the highly impacted sites are, in the hundreds, and the reference streams are around 30. And kind of these mid-impacted areas here are in the 100 range typically. So just give you an idea of how you can use the SON data to look at the water quality. And then you can relate the water quality and water chemistry and even the biological responses of the critters that can live there. Remember, biomonitoring is a way to look at water quality based on the animals that live in the water 100% of the time. The second best thing is this probe thing here. And other times we can just go out and grab a water sample and then analyze how much is in it as far as specific toxins or salt and whatever. But you can see that the more impervious surface you've got, or less forested sections you've got, result in this higher dissolved contaminant load in the streams. And the more forested you are, the lower you've got. So that's a really tight relationship that we were able to show. This is another way of looking at it. This is now looking at impervious surface in black and everything else is in white. And this is just looking at forested in green and everything else is in white. So we can get down to a 1 meter resolution with the LiDAR data the state of North Carolina provides every 4 years. And so we started in 2008 collecting data here, and we have the 2010, 14, and 18 LiDAR data that we've been using. So we have this high resolution GIS layer that we can use, and we're looking at the changes that happen every 4 years with development over time in the Boone area. And there's certainly been some significant changes in impervious and forested areas. For the GIS folks, the Global Information Systems folks in geography and planning, they're also looking at other things like aspect, negative slopes, vertical resolution, and they can even do flyovers with this LiDAR now and look at the vegetation that's growing along the streams with really high resolution. So this is beyond my understanding. I don't really use this for my work, but there's all kinds of applications for it as far as development within watersheds and what you can understand about the current state of things and the water quality. All right, so this is some of the work that my grad students did. We looked at all of these 8 data sites, datason subbasins, and collected macroinvertebrates from them. So these are all the bugs and snails and worms that live in the streams, and determined the North Carolina Biological Index using the NCDEQ standard operating procedure. And we plotted it in a regression here against the median specific conductance from each of our data sites. And so each of the little diamonds here is representing the specific conductivity. And you can see here's the reference sites that are around 30, and this is the Boone Creek sites that are in the hundreds. These are the Middle Fork and East Fork sites. As far as family level biological index here, what you need to know is that the lower the value, the higher quality the water is, meaning this is based on tolerance values from 0 to 10 for each species or family of critter we have in our streams here in North Carolina. And the lower the value, the higher quality the water it is. So it's an inverse relationship. So what you're seeing here is as basically the salt levels go up in the stream or contaminant level goes up in the streams, the biological index values go up, which is a bad thing. And you can see here that, anything between 0 and 3.75, which is definitely including this first group here, is in kind of a group of low impact development. And this middle group here is in the mid development range. And then where we get high development within the town of Boone proper, we got huge impacts on the aquatic critters that can live there. So this relationship is described by this best fit line here, R squared line. It's 0.87. That's unheard of for ecological data. So what this means is this conductivity is demonstrating a very tight relationship with the biological community's response to the water quality. So the biomonitoring is doing a great job of determining the impacts of development on the health of our system. We did the same thing with fish, and fish were not as useful, actually. We only found one fish, the mottled sculpin, that seemed to be responding negatively to these high levels of salts in the streams, and they weren't living in places they should be. But still, the trout were, amazingly. Some of the work that geography and planning also does is look at this process called hysteresis, and it's kind of difficult to explain, but let me just pick one here. So we are looking at Boone Creek, so one of our impacted streams, and we're comparing it to Goshen Creek, one of our reference streams. And the rising limb and falling limbs are color coded here. So what you're looking at is as discharge goes up during a rainfall event, you're looking at the rising limb right here. So let's see, if we started off at about 25 or 20 cubic feet per second before the rain started, that corresponded in Goshen Creek to a chloride level of about 22. And as it started to rain, those chloride levels actually creeped up just a little bit. Remember, this is a natural stream. So there's hardly any change during this whole storm event. And then as it drops back down again, it basically recovers to that same level. So we're only getting 1 milligram per liter, or 1 ppm change in the amount of chloride, which is also, the road salt. Big source is the road salt in this healthy stream, which is mostly forested. But if you look up here in Boone Creek, the range of chloride levels starts at 110. Okay, so it's 5 times higher than Goshen Creek to start with here. And in this one here, it's more than that, right? So basically, we can look at what's happening at the front end of these storm events as it flushes the salt off the roads, enters the creeks, and we can measure those pulses of chloride and other contaminants as the rainstorm builds up. But sometimes it actually goes down during the rainfall events, and that's just because it's diluting the amount of salt that's in the water with huge amounts of rain. So this is another way that we can use our data. Recently, we added a collaboration with NASA, and we're hoping to get some NASA funding, which is, we'll see if that happens. But we're trying to measure carbon dioxide and methane releases from high mountain water streams. So apparently, NASA is not currently using stream flux of greenhouse gases as part of their budget for understanding the Appalachian Mountains capabilities for a carbon sink. We know that our forests are good carbon sinks, but what is not being factored in is just how big a source these mountain streams are. So I worked with the high school kids this summer using these simple probes. These are about 250 bucks. These are simple carbon dioxide probes, and one of them is measuring what's coming, what's measuring, or I'm sorry, what's the ambient level of CO2 in the air. One of them is measuring what's dissolved in the water below it, and it's got a little sleeve on it to allow it, impervious sleeve to allow the gas to escape from the water into the air above it. I'm sorry, this is the one doing that. And this is the one that's actually just measuring what's in the water. And basically, from a month's summer work and then extrapolating across the number of miles we have of Appalachian mountain streams, we're talking about gigatons of carbon released from these streams. So this is going to change some of the modeling for NASA. We are in collaboration with a scientist from NASA that actually has 2 degrees from App State, so they have a connection back to with Ashe County and Boone. Um, and we're hoping to make this a middle school and high school science class uh, citizen science project if we get funded. We've also used similar projects away from the high country, looking at the impact of concentrated animal feed operations across the state of North Carolina. So this is a map you may or may not be familiar with, but the purple dots are poultry operations and the red dots are hog operations. And I've got a long-term project here in Sampson and Duplin County looking at the impact of air and water quality and drinking water down there impacted by CAFOs. And currently, our research faculty that have joined the AppAqua efforts are from 6 different programs across campus: chemistry, geology, and environmental. I'm sorry, yeah, geology and environmental sciences, geography and planning, biology, computer science, and our research institute for energy, environment, and economics has a data scientist that they just hired who will be helping us with getting our data published. All right, so I'm going to stop there. I'm sorry if that was a little long-winded, and see if anybody has any questions.
I don't have so much of a question, but just a comment that that's really wide sweeping work that's really important and fascinating. So thanks so much for sharing. I grew up in Boone, so I recognize some of those places, and I'll have to
Oh,
keep
good.
that out whenever
Yeah,
I go up there for your probes out there. That's awesome. And cool that
yeah,
you're getting like high school students involved too. It's a good
yeah.
project.
They don't think about jobs in the aquatic conservation area, but they're universal, and so it's a great opportunity for them to get involved in something meaningful, and then usually helps them get into a really good college too.
Yeah, definitely. All right, any other questions?
There's something in the chat. Oh, that's just a comment from the AI reader.
Cool.
Carolina, will you be sending this recording out?
Yeah, yeah. Normally we upload them to YouTube and I can share the link whenever it's ready.
Oh, that would be great. Thank you so much. I appreciate it because I missed the first part. And I'd like to see all of it again.
Yeah, definitely.
Thank you.
Well, if anything pops up, Carolina, feel free to email me. And I know you guys collaborate with some of the local conservation groups as well. You mentioned in your email to me the Catawba Riverkeeper
Hmm.
and Who else? Was someone else? Oh, the Foothills Conservancy.
Hmm.
Do you ever work with the Lake James Environmental Association?
Yeah,
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 yeah.
definitely. Yeah, I don't know if anyone from the Riverkeeper is on this call right now, but I talk to them fairly frequently, and we'll definitely share this out to them as well because it sounds similar to the kind of monitoring that they do or would be interested in.
Right, exactly. Yeah, we've
Mhm.
collaborated with them, and I try to get to their meeting every year. One of my old students is the Northern Catawba River Keeper, um,
Is that Grant?
Grant Holder. Yeah, I'm sorry, Grant Buckner. Um,
Yeah, yeah,
so,
cool.
so that's kind of the type of folks that come out of my lab. They're, looking to be full-time river conservation folks, and luckily North Carolina's got a lot of river keepers, so a lot of positions for those kinds of folks to get involved in.
Yeah, that's awesome. Well, thanks so much for being here.
Of course. Thanks for the invite.
And yeah.
It's good to
Um,
meet you, Carolina.
yeah, good to meet
And
you too.
what's your position there?
I have been in an environmental education outreach role, but I'm transitioning more to take over some water resources things, so to be a natural resource administrator.
Okay.
Mhm.
You didn't go to App State though, did you?
No, I didn't. I went to Wake
Okay.
Forest
Yeah,
University.
cool. All right. Interesting. All right. Well, so good to meet you. Thanks again for the invite, and hopefully this was useful in some way.
Yes, definitely. Thank
All right.
you.
Take care. Bye.
All right. At this point, I'll go ahead and talk about some different projects we have going on at the COG in the Natural Resource Department. So first of all, we have the septic system repair project. This is something that Johnny was working on and that now I'm starting to work on more. And so um, we have a lot of projects, past projects starting in 2013 and then again in 2017, there was another batch. And then we have funded this year to do another batch of them. So basically, the way it works is that when someone in Caldwell, Alexander, Catawba, or Burke counties has a failing septic system and they're in a location that to where that could be really hazardous for water quality, they're near an impaired stream, they're able to apply to our program, and we can use grant funding to help cover the cost of their repair because they're very expensive, and a lot of folks can't afford them. And so we help them out, and then if they ever sell their house, they will pay the loan back, and it'll go into a revolving fund, and then we can use those funds to help fund more septic repairs. So there are a lot of nuts and bolts to figure out with this project, but so far we have 21 applicants approved, 8 clients in the bid or repair process. We use local contractors um, to do the work, and then 5 projects have been completed. And so hopefully we'll be able to get the ball rolling even more and do more and more projects with the remainder of the year and the grant cycle. We also have a tree canopy education project that's ongoing. It started last year, as grant funded by the U.S. Forest Service, Urban and Community Forestry for the completion of a STEM-based educational project for 5th and 8th grade students. So we worked with 3 schools, William Lenore in Caldwell, Longview Elementary in Catawba County, and Heritage Middle School in Burke County. And basically, we're going in and doing lessons about tree canopy benefits, heat islands, air and water quality. And then last year, we actually had an arborist come in and help the students create a tree planting plan for their school campus, which is really cool. And that project won a NATO Impact Award. And so we got funded to do it again this year, and that's actually kicking off pretty soon. We have teacher training next week, and then the first week of lessons in those 3 schools in November, December. And this year we're teaching very similar topics, but this time we're focusing on actually planting trees, helping students do that, and then create like a tree maintenance plan. And so, of course, the focus is on trees, but we always spend at least 1 or 2 days on water quality. I bring in the Enviroscape, do some lessons about soil and how water and soil interact and all of that good stuff, just because water quality is such an important part of planting and upkeeping trees and understanding their importance for the environment. And I've been out at some festivals doing the typical stormwater outreach that we do, the Blackberry Festival in Lenore, the Waldensian Festival in Valdez, the Morganton Festival. I also did a program at Lake James State Park with the YMCA. So that was really fun to get students out there exploring a new body of water. We reached over 1,000 people through just those festivals, which is pretty awesome, pretty cool. And then I also host litter cleanups to try to keep some of that litter out of our waterways. So, in the last few months, we had a cleanup of the Lenore Greenway in July and East Cemetery Street in Maiden in August. And through just those two, we removed about an estimated 525 pounds of litter. Thanks to all the volunteers that showed up. I'm really working on expanding our volunteer list and sending out monthly newsletters and providing these opportunities to get folks in our counties engaged. I put the QR code on the slide in case any of you want to sign up to get those newsletters or share that out. Would love to have more volunteers come out to our events because they are pretty impactful. I'm also applying for a grant to launch an Adopt a Drain program in Lenore. I think that would be an awesome way to get more folks involved in Caldwell County where they can actually see a storm drain near them, sign up to adopt it, and commit to clearing it of debris and litter between rain events, just making sure that that system is functioning properly. And that's a great educational tool as well. And then talking about some things that are around the corner. I'm going to be at the Granite Falls Festival on Main on Saturday, and then doing a cleanup in Sawmills on Sunday. So if you're around Caldwell County, feel free to stop by either of those things. I'm also doing a stormwater program at the Maiden Branch Library. And then the Catawba River Sweep is being held on October 4th. That's a really big event. I think it's the single biggest litter or river cleanup in the Southeast. It's on a single day. And so that's Catawba River Keepers Project, but they have locations on Lake Hickory and Lake James. And so feel free to sign up for that, find a location near you, send that out to people who might be interested. It's a really cool thing to be a part of. And then I'm always posting event updates on Facebook, so you can follow us there. We're going to have our next water resource meeting in December, so stay tuned for that. Since Johnny has left the COG, some of you remember Johnny Ware. Of course, he was here for so many years, and we have big shoes to fill with him, but I'll be taking over these meetings for the time being. And we are going to be hiring a natural resource manager to help take care of some of his work and also some of the stormwater compliance work that Haley Hopkins was doing. So if you know anyone who would be a good fit for taking over some of those projects, please reach out. We'd love to have people join our team and so we can spread our impact in this department. So yeah, that was kind of a broad overview of what I've been working on. Are there any questions or things that you all are working on that you want to share in the region? All right. Well, with that, we'll go ahead and close out the meeting. Thanks for being here, and I'll send out the recording, like I said, and also feel free to reach out anytime that you have an idea for this committee or have an idea to share. And I'll be sending out some more information about the next meeting in December. All right, everyone, have a good rest of your day.